I want to show how I wrote a JSON parser in about 2.5 hours this morning. I wrote a JSON grammar and went all the way to creating a Lisp file out of it, created at 9:22 a.m. and finished at 12:02 p.m. with a result that I wanted, which was a particular diagram that I had scanner.draw.io, and I wanted it in Lisp. I wrote a grammar based on JSON.org, their grammar diagram here. So basically, we either see objects or arrays, one or more of, and then an object is either a name. I've strung this out. There's probably ways to do this a little more concisely, but an object is a name-value pair. The way I wrote the grammar is blunderbuss approach. I didn't bother optimizing the grammar, but I made sure that the longest pattern comes first. This is due to the peg rules that say it finds the first match and then assumes that matched at that point. Here we're saying that an object is a open brace, a name-value pair, any number, one or more comma name-value pairs, and then a closing brace. And that's tagged as being object underscore multiple. Likewise, an object can just be a single name-value pair inside braces, or it could be an empty. If you look at name-value pair, there's a white space string, white space colon, white space value. And if you look at this diagram, I claim that matches the diagram. And then we did that for arrays and values. I needed, because the white space business, I needed value 1 here and so on. I used lowercase rules in OhmJS because I didn't want to deal with the possibility that spaces in strings would get annihilated. I went to the Ohm editor website and wiped out the default grammar that they have there. I took a copy of the grammar that I had, paste, and originally I got some errors down here. I don't have any right now. I took a copy of my test file, went to the examples, and pasted it in, and waited for it to parse. The green bar here at the side says it parsed okay, according to the grammar. And over here is the parse tree. We can collapse things and look at things in more detail and so on. As you mouse over these, it lights up the corresponding rule on the left side and shows you what should be there. Then you have options down here, explain, parse, and show spaces. Once I had the grammar working and debugged, I grabbed a copy of it and stuck it in another file called json.rewrite. And then I ran it through a little tool that I had here. And I need to modify a few lines that fit the tool. There we go, it worked. It produced an identity grammar. It took the grammar and rewrote it as a rewrite file, an identity grammar. It created names for things that don't fit JavaScript very well. So for example, here we are on the grammar, 4 digits. So this string here got assigned a fake name of _38. The next string under EU got assigned the fake name _39. And then it went hex, 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 hex 4 times. And it renamed the rule string entered 4 hex digits. We do that and save it into a file somewhere. Then I go back to my working directory and I run json2cl.bash. We'll look at that. json2cl.bash, which is really just capture of a command line that I don't want to repeat more than once. It calls the T2T translator, which I'm calling nanoDSL. It uses the library from that place. It uses the grammar I just wrote. It uses the rewrite that we just wrote. It's going to be the identity rewrite. All we're doing is checking to see that it works, that there's no ridiculous errors in it. There's an empty JSON support file. The reason for that will become clear at another time. This project doesn't really need much. We're going to grab the JSON file that we wanted, and then we're going to output the final result in a .lisp file. Then we go back here and we run it, and we get an error which says I've got junk here that was created by the make file. I save it, I'll run it again, and it'll give me another error. And it says expects a % rewrite, which is a more recent change since the tool was made. Now we're getting errors due to the fact that the tool doesn't recognize duplicate names when it's generating the JavaScript. So I'll fix those. There's name value pair, white space appears in a couple of places here and here. So I have to differentiate those. Name value pair, I'll make that an S. And somewhere else I had one of those going on too. There's WS's here, WS1, WS2, WS3. And we'll put them in right order here. Value is used twice here. We'll make that a values, which will differentiate it. And then hex down here will have a problem also, and I'll fix that. 2, 3, 4, and 1, 2, 3, 4. And then let's go. Yes, that was it. So we'll just run that. There are no more errors. It's generated the file that we expected it to generate, which is scanner.json.lisp. And it produced a copy of the JSON input file, mangled a bit by the parser. In this case, it grouped all the commas together that it found because of the way we wrote the parse. I did it here again. We don't really care because all we're doing is checking to see that it works, that it doesn't fail in a horrible way. In a moment, we're going to hack on the rewrite file anyway and get rid of this sort of stuff. The thing I'm battling here is in CLJSON, it takes these keys and turns them into Common Lisp symbols, which, because Common Lisp is such an old language, it uppercases them, and I want it to keep the case significant. And now it's time to hack on the rewrite file and make it emit stuff that looks like Lisp that I want. In this case, I don't want these brackets that they supplied, so I'll just put in Lisp brackets. That'll just go to white space. This here will get expanded automatically because of this plus sign here. So we'll get more than one or more. We'll put that in there. Gonna wipe all this out, put in what I've already done. And so I've modified these. For example, I've taken name value pair and rewrote it as a Lisp dotted pair. And I've dropped all the white space and colons and all this stuff. I just ignore that stuff. It's JavaScript is what gets generated from this stuff. JavaScript doesn't care if you ignore parameters, doesn't raise type errors, that sort of stuff. I want to keep this video kind of short, so I'll just jump right ahead. I've made modifications to the rewrite file. I've touched most of these rules here. I haven't touched these rules. This needs some consideration. I'm going to run the bash file, which will run the T2T transpiler and produce this file here. Let's run it. There it goes. And we'll load up the file, scanner.json.lisp. And there it is, a list, a set of lists in machine readable format, not particularly human readable format. If I want to make it more readable for debugging purposes, I replace string open parenthesis with new line open parenthesis. I select the whole thing and then indent the region with the Lisp indenter, and it looks like valid Lisp, and I'll continue from here. I'm going to read that into the project I'm working on and proceed from there.